All right, I think now we will now talk about the weight of a person moving in an elevator. Now, have you experienced when you are in an elevator and suddenly the elevator picks up acceleration upward and your knees bend? Now, have you experienced that? What is the reason? The reason is the elevator suddenly applies an extra force upward. You see, before the elevator moves, your weight mg is acting vertically down, and the elevator applies the normal force upward. They are equal and opposite. When the elevator wants to accelerate upward, there must be a net force upward. And what will be therefore the total force upward? It will be mg plus ma, the force needed to produce that acceleration. And that means you will be pressing, or the elevator floor will be pressing on you harder. It means if you are standing on a weighing machine, you will weigh more. Why? Because the elevator floor will be pressing harder. That means you will be pressing harder on the weighing machine. You will feel heavier. On the other hand, if the elevator is accelerating downward, you feel as though something is moving, giving way from your feet. You feel weightless. All right, let's talk about that. When you stand inside a stationary elevator, you press the floor of the elevator with your weight. There you are in the elevator. Well, this is the elevator moving up, this is the elevator moving down. I haven't got where the elevator is stationary. Now, if the elevator is stationary, the floor of the elevator presses you upward with the same force. That means if you are standing on a weighing machine on the floor of the elevator, which is not moving, it will read your actual weight. Now, if you stand on a weighing machine, that will read mg, your actual weight, because that is the force pressing onto the elevator floor. If the elevator now moves up with an acceleration a, the floor of the elevator will push you up with an additional force ma. You see, before it started accelerating, the floor applied a force equal to mg, so that there is no net force on you. Now, the elevator wants to produce an acceleration on you upward. That means it must produce an additional force on you. So what is the force now the elevator applying on you? Is mg plus ma. And you in turn will press the elevator floor back with the same force. That means your weight will now be greater. So the scale will now read mg plus ma. So here you can see the elevator is accelerating up and you are buckling down. Well, I'm exaggerating though. But you are pressing onto the floor of the elevator with a greater force. That is mg plus ma. You will feel heavier. On the other hand, if the elevator moves down with an acceleration, then the force ma will be downward. That means the floor of the elevator will press on you with the force mg minus ma, and that will be therefore what the scale will read. You will feel weightless. So, how do you want, if you want to lose weight, therefore what do? There is no need for any dieting. You can go to an elevator and make the elevator go down with an acceleration. Your weight as is read by the machine will be mg minus ma. Well, what happens if the elevator cable breaks and the elevator falls freely? If the elevator begins to fall, will you be pressing onto the elevator floor at all? Well, if you are now on the elevator floor, the floor is falling, you are falling, you are not pressing on the elevator. What will the machine, the weighing machine, read? 0. You will be weightless. So you are falling freely, the elevator floor is falling freely. That means anything that falls freely will be weightless. That's right. If you want to lose all your weight, all you need to do is go to the top of a big building, jump down. During the time you are falling freely, you are weightless. That's right. Now, let me see if I can demonstrate with this machine here. Well, this is a spring balance, a scale. Now, this is the elevator at rest. It reads the actual weight. Now, suddenly, if I move up, now can you see what happened? Suddenly, if I move, this comes down. As it comes down, it is moving, it is reading more. You can see the moment I move up, the weight increases. And if I fall, the reading decreases. If I let it go, you can see the reading is 0. While falling freely, this will read 0. So the weight of a freely falling object is 0. That means if the elevator is accelerating upward, your weight as is read by the weighing machine will be mg plus ma. If it is moving down, the weighing machine will read mg minus ma. And if the cable breaks, there you are weightless. That's right, you can fly around inside the elevator. Let's do a problem. A 70 kilogram person stands on a scale in an elevator. What is the weight? What weight in Newton does the scale read if the elevator is at rest? Well, if it is at rest, it will read his actual weight. Be moving up with an acceleration of 0.525 meter per second squared. What will the elevator read? What will the weighing machine read? It will be mg plus ma. If it is moving down with an acceleration, it will read mg minus ma. So part A, when the elevator is at rest, the scale will read the actual weight mg, that will be 686 Newton. And if the elevator is moving up with an acceleration a, the scale will read mg plus ma. mg plus ma, that is, this is mg plus m times a, that will be 722.75 Newton. Now, have you heard of people who go in spaceship talking about experiencing 2 Gs and 3 Gs and so on? What does that mean? If a rocket suddenly takes off with a tremendous acceleration, you know, when it takes off with a sudden acceleration, the seat will be pressing onto you so hard, you get crushed onto that seat. Your weight will be mg plus ma. If that acceleration is 3 times the acceleration due to gravity, you are experiencing 3 Gs. And that needs a lot of experience, otherwise your whole system will get crushed. On the other hand, if the rocket is falling freely, have you seen in air shows the plane coming diving down? That time you experience weightlessness. While the plane is climbing up, you will experience 2 Gs and 3 Gs. You are getting stuck onto the seat with a tremendous force. Well, So when the elevator moves up with an acceleration a, the scale will read mg plus ma, that is 722.75 Newton. When the elevator moves down, well, this must read move down. Okay, when the elevator moves down, what is the situation? This must be corrected to down. The scale will read mg minus ma, and that will be 649.25 Newton. Okay, let's do another one. A man stands on a scale in an elevator that has an upward acceleration a. The scale reads 960 Newton. When he picks up a 20 kilogram box, the scale reads 1200 Newton. Find the mass of the man, his weight, and the acceleration. Okay, that's a good problem. Let's set it up. Let the mass of the man be m kilogram. That is what we need to find. The scale reading when the elevator is accelerating up with an acceleration a is mg plus ma. Is that right? Yes. That means 960, this is the reading of the scale, that 960 equal to mg plus ma, 9.8 m plus ma. We need to find m and we need to find the acceleration. Now, that means we need one more equation, is that right? Alright, well, one more equation can be obtained when the man picks up the 20 kilogram box. What happens? When he picks up a 20 kilogram box, the scale reads 1200 Newton. That means this m now becomes m plus 20, and then the scale reads 1200. Well, if you want, let's solve the first equation for a. A equal to 960 minus 9.8 m over m. Well, and that will be 960 over m minus 9.8 m over m, and this is now an equation for a. When he picks up a 20 kilogram box, the total mass now is, this m becomes m plus 20, and then the scale reading becomes 1200. So the scale reading becomes 1200, m becomes m plus 20. We have 1200 equal to 9.8 times m plus 20 plus m plus 20a. And what I'm going to do is replace this a. I'm using a substitution method here. You see, I have used the first equation to solve for a, and I'm going to substitute this a by that value. So a is 960 over m minus 9.8. Now, this is our equation. That will be 1200 equal to, what I have done here is, if you want to watch there, I took m plus 20 as the common factor. You understand that? If you put m plus 20 as the common factor, what is left in here will be 9.8 plus what is left here is